Hello students, today we will see the next topic is line coding. Line coding is the process of converting digital data to digital signal. Here this digital data into digital signal. Line coding converts the sequence of bits to a digital signal. At the sender, digital data are encoded into a digital signal at the receiver, and the digital data are recreated by decoding the digital signal. See, this is the diagram. Here the sender and this is the digital data. Digital data is encoded, then digital signal encoded into the digital signal, and then digital data again decoded and it is converted into the digital data. This is at the receiver side. Then line coding characteristics. The common characteristics of the line codings are: first is signal element versus data element. A data element is the smallest entity that can represent a piece of information. This is the bit, and in digital data communication, a signal element carries data element. A signal elements is the shortest unit time wise of the digital signal. That means, in other words, the data elements are what we need to the send, signal elements are what we can send, then data elements are being carried and signal elements are carried. Then the this is second is data rate versus signal rate. This data rate defines the number of data elements, that means bit sent in 1 second, and the signal rate is the number of signal elements sent in 1 second. Then third is bandwidth. Bandwidth is the actual bandwidth of the digital signal is infinite and the effective bandwidth is finite. The digital signal that carries the information is non-periodic, and the bandwidth of the non-periodic signal is continuous with an infinite range. However, most digital signals we encounter in the real life have a bandwidth with finite values. That, in other words, the bandwidth is a theoretically infinite, but many of the components have such a small amplitude that they can be ignored, and the effective bandwidth is finite. Then baseline ordering. Then in decoding a digital signal, the receiver calculates a running average of the received signal power, and this average is called as the baseline, and a long string of 0 and 1 can causes a drift in the baseline is called as the baseline ordering. Here the make it difficult for the receiver to decode the correctly, and the good line coding scheme need to prevent baseline ordering. Then DC component. When the voltage level in a digital signal is constant for a while, the spectrum creates very low frequencies, result for Fourier analysis. These frequencies around 0 called as a DC, that means direct current component, present problems for a system that cannot pass low frequencies or the system that uses electrical coupling via a transformer. Then self synchronization. To correctly interpret the signal received from the sender, the receiver bits intervals must correspond exactly to the sender's bit intervals. If the receiver clock is faster or slower, the bit intervals are not matched and the receiver might misinterpret the signals. Then seventh characteristics is built-in error detection. It is desirable to have a built-in error detecting capabilities in the generated code to detect some of or the errors that occur during the transmission, and some encoding scheme that we will discuss have capacity of some extent. Then immunity to noise and interference. Another desirable code characteristic is code that is immune to noise and other interferences. Then cost of implementations. A complex scheme is more costly to implement than a simple one. For example, a scheme that uses 4 signal levels is more difficult to interpret than one that uses only 2 levels. Then next concept is line coding scheme. We can divide line coding scheme into the three basic categories. First is unipolar, then second is polar, and third is bipolar. Here first one is unipolar. The unipolar, all the signal levels are on one side as per name unipolar of the time axis, either above or below. Then first is non-return to zero. So this is called as NRZ, non-return to zero. It is unipolar line coding scheme in which positive voltage defines bit 1 and zero voltage define bit 0. That means here voltage positive and zero voltage. Positive voltage defines 1 bit and zero voltage defines 0 bit. Signal does not return to 0 at the middle of the bit. This is called as the NRZ, that means non-return to 0. For example, suppose here data is given 10110. In this encoding approach, bit rate is same as the data rate. Here, see, this is the we have already positive for positive voltage defines the 1 bit and the 0 voltage defines the 0 bit. Here this is the positive and this is the 0. Here 1 is positive, so 1 is upper side, then 0 is here, then also here 1. This data is already given in example also. So then 1 for positive, here is positive, and 0 for at the 0. That means 0 voltage defines the 0 bit. This is the encoding approach for non-return to 0 approach. Then drawbacks of unipolar. Unfortunately, a DC component present in the encoded signal and there is a loss of synchronization for a long sequence of zeros and ones. It is simple but obsolete. Then unipolar scheme is costly than polar, and this scheme is not used in the data communications today. Then second is polar scheme. In polar scheme, the voltage are on both sides. That means it uses the two voltage level. One is positive and another is negative. Four different encoding scheme shown in this diagram. Here polar, NRZ, RZ, and biphase. NRZ classified into two types, NRZL and NRZI. L stands for level and I stands for invert. Then RZ and then biphase, it is subdivided into the Manchester and differential Manchester. Then see one by one. Non-return to 0, that means NRZ polar scheme. The polar NRZ is the most common and easiest way to transmit the digital signal. It uses two different voltage level for the two binary digit. Usually a negative voltage is used to represent one binary values and positive voltage to represent the other. The data is encoded as the presence or absence of the signal transmission at the beginning of the bit time. In NRZ, encoding the signal level remains same throughout the bit period, and the two version of the polar is NRZ L and NRZ I. Their NRZ L stands for the level, and the level of the voltage determines the value of the bit. Here positive voltage defines 0 bit. Every polar scheme having different rule. So here the positive voltage defines 0 bit. This positive voltage defines 0 bit and negative voltage defines 1 bit. And in NRZ I stands for invert, and the change or lack of change in the level of the voltage determines the value of bit. If there is no change, the bit is 0. Here the rule is no change, the bit is 0, and if there is any change, then bit is 1. See, this is the diagram. Here the representations for the polar NRZL and NRZI. Here this is the data passes 0 1 0 0 1 1 1 0. Then here first is NRZL. Remember, this is the rule for NRZL. Positive voltage defines 0 bit and negative voltage defines 1 bit. So here this is the positive voltage, so 0, if entering 0, then this is the representations at here, and then second is 1, then 1 for negative, so here the negative 1 for negative side, then 0 at positive. Here this is the graph, here positive and here negative, so 0 at the positive and 1 at negative side. Here this 0 0 at the positive and 1 1 at negative, then here is also 0 at positive. This is the NRZL L scheme. Then second is NRZI. This is the inward scheme. Inward scheme having a rule that is no change, the bit is 0, and if there is any change, then bit is 1. इथे NRZ I स्टँड्स फॉर इन्व्हर्ट. आता ज्यावेळेस तुम्ही इन्व्हर्ट करणार आहात त्यावेळेस इथे आपल्याला डेटा पास केलेला आहे, तर डेटाचं आपल्याला सिग्नलमध्ये कन्व्हर्जन करायचं आहे. तर डेटा 0 आहे, तर रूल आपल्याकडे आहे नो चेंज, द बीट इज 0. जर आपल्याकडे कुठल्याही प्रकारचं चेंज नसेल तर आपण बीट आपला 0 असणार आहे, म्हणजे 0 बीटला तुम्ही कुठल्याही प्रकारचे चेंजेस करायचे नाहीत किंवा इन्व्हर्जन करायचं नाही. पण ज्यावेळेस तुम्हाला इथे चेंज असेल त्यावेळेस तुम्हाला इन्व्हर्जन करायचं आहे 1 जर आलेलं असेल तर. तर यामध्ये बघा NRZI कशा पद्धतीने केलेला आहे. तर डेटा सपोज इथे 0 आहे, तर 0 असल्यावर आपल्याला इन्व्हर्जन आपलं चेंज होणार नाही. त्यानंतर ज्यावेळेस तुमचं डेटा हा 1 असणार आहे, त्यावेळेस जर आपल्याकडे 1 आलेलं असेल तर आपल्याला काय करायचं आहे, इन्व्हर्जनला चेंज करायचं आहे. सो इथे काय केलेलं आहे, इन्व्हर्जन इथे चेंज केलेलं आहे. आता नेक्स्टला काय आहे, 0 आहे. 0 आला तर आपल्याला काय करायचं नाही, इन्व्हर्जन चेंज करायचं नाही, म्हणून याला काय केलं आहे, पुढे घेतलेलं आहे. पुन्हा काय केलं आहे, 0 आलेला आहे, तो सिग्नल आपल्याला इथे 0 आल्यानंतर चेंज करायचं नाही, म्हणून मी सिग्नल काय केलं आहे, पुन्हा एकदा असा पुढे घेतलेला आहे. त्यानंतर 1 आलं आहे. 1 आल्यानंतर आपल्याला काय करायचं आहे, इन्व्हर्जनला चेंज करायचं आहे, म्हणून आपण काय केलं इथे इन्व्हर्जन चेंज केलं आहे. आता रूल आपल्याकडे असा आहे, 1 आलं की इन्व्हर्जन चेंज करायचे. आता पुन्हा आपल्याला नेक्स्ट डेटामध्ये काय झालं आहे, 1 आलं आहे, म्हणून पुन्हा काय केलं आपण, डेटा चेंज केला आहे. पुन्हा दुसऱ्या याच्यामध्ये डेटा काय आला आहे, 1 आला आहे. 1 आलं तर आपल्याला सिग्नलला चेंज करायचं आहे, 0 आलं तर सिग्नलला चेंज करायचं नाही. आता इथे 0 आहे म्हणून आपल्याला सिग्नल चेंज करायचा नाही. तर हा एक रूल आहे इन्व्हर्जनसाठी. जर 0 आलं तर आपल्याला सिग्नल चेंज करायचे नाहीत आणि 1 आलं तर आपल्याला सिग्नलला काय करायचं आहे, इन्व्हर्जन करायचं आहे. Then advantages of NRZ coding. Detecting a transition in presence of noise is more reliable than to compare a value to a threshold. Then NRZ code are easy to engineer and it makes the efficient use of the bandwidth. Then disadvantages, baseline ordering is a problem for both methods and it is twice in NRZ level. If there is a long sequence of 0 and 1s, then NRZL, the average signal power becomes skew and the required might have difficult in identifying the bit values, and NRZI, this is the problem occurs only for the long sequence of the zeros. Then synchronization problems, sender and receiver clocks are not synchronized, also exist in both scheme. Long sequence of zeros can cause problem in both scheme, and long sequence of ones affect only NRZ level. Another problem with NRZL occurs when there is a sudden change of polarity in the system, and NRZL and NRZI both have a DC direct current component problem. Then another type is return to 0 RZ. The main problem with NRZ encoding occurs when the sender and receiver clocks are not synchronized. The receiver does not know when one bit has ended and the next bit starting. So there is one solution is return to 0. First time we have seen the return to 0 scheme, which uses three values: positive, negative and 0. So in RZ, the signal changes not between bits but during the bit. From these figures, we see that the signal goes to 0 in the middle of each bit. It remains until the beginning of their next bit.